we're going to talk about odd functions. Okay? Now, just like when we were talking about the even function, I want us to look at what the exponents are on these three equations we're going to look at. So the exponent for this first one right here is 3. So our exponent is 3. The second one here, our exponents, we have an exponent here, here, and here. Okay, we have an exponent of 5. We have an exponent of 3. And here's the sneaky exponent that's not written there, but we have an exponent of 1. Okay, now let's look at this third problem. I have exponent of 3. I have an exponent, again, the sneaky exponent, the one that's there but we can't see. Exponent of 3 and an exponent of 1. What I want you to notice, real easily here, is I want you to notice all these exponents are odd. There is not a single even exponent. They are all 100% odd. Now, just like with the even functions, I want us to look at what's going on with the table of values. So I'm going to slide this over. Let's look at the table of values for this first one. This first one was y equals x cubed. And it's sort of the parent function of cubed functions. And let's look at what's going on with our table of values. Okay? Just like with the even functions, I've put in opposite values of x. But let's look at what's going on with the y values. What happens here? I have the same number, but I have different signs. Opposite value here and here. What do we see happening here? And again, there and there. Does this pattern hold true for these other two odd exponent functions? Well, let's find out. Slide this one over. Okay, here's my opposite values of x. I get opposite values but same number. Opposite values of x, opposite values but same number. Opposite values of x, opposite y's, same number, different signs. It's holding true for the second one. Let's see if it holds true for the third one. Okay, so opposite values of x, same number, different signs. Opposite values of x. Looks like I have a pattern. I'm batting 3 for 3, as they say. At least somebody says it. Looks like I have a pattern. Looking at the whole page, when I have opposite values of x, I have the opposite values of y. Same number, opposite values. Now, let's look at what happens with our pictures. Remember now when we did the even functions, I also looked at the pictures. So again, I went to Desmos and looked at them on Desmos. Now, the thing about odd functions, it's not about the line of symmetry, it's about rotational symmetry. Meaning that if I rotate it 180 degrees, I get a picture that looks exactly, no questions out, exactly the same. So let's rotate this one. Interesting. So if I flip back and forwards, I don't see any difference between this one. Oops. They look the same. All right, let's try it with this other one. Okay, our second one. Here's my polynomial. Interesting, isn't it? Sort of looks like a ribbon. I'm going to rotate it. Let's see if I rotate it back and forth, do I have the same picture? So flip, 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 flip. The only way I can tell that it's different is my numbers on my y-axis are written on the different side. It looks exactly the same when I give it a 180-degree turn. So let's check this very last one. Check this very last one and see if it does too. So I'm going to flip it. Oh, it doesn't want to flip. Oh, interesting. But you can trust me that it does the same thing. With that said, we can say that our odd functions have rotational symmetry about the origin, 180-degree rotational symmetry about the origin. And this means it is order 2. Remember what we learned about rotational symmetry. With that said, everything's over and done with. You have learned about odd functions.